Oh, hi there. Thanks for showing up for your learning. This is Grant, the SAT Genie, coming out of my lamp to review with you this particular SAT question. It looks very challenging from at first glance. And I'm going to show you how when your basics are really strong, this question falls apart rather easily. And I'll show you what those basics are and how you can use challenging questions like this in your and your kids' SAT prep. So let's take a look. We're given this value here, or this expression, that 3 multiplied by x minus y is always equal to 12. And then we're asked, what's the value here? Okay, of 8 to the x divided by 2 to the y. I can show you a few ways to get through this question if you're stuck and your basics are not there. But before that, let's go to the basics. So this question relies on several ideas, and they're all called exponent laws. Understanding what these things are called helps you look them up on YouTube and find tutorials or ask great questions in class. So that's one of the benefits of small group instruction, is that people can come together, learn the correct vocabulary to talk about these things, and build their knowledge. So the first exponent law that we're going to look at is the product of powers law. And I'm getting all of these questions from over here in Delta Math. This is an online set of math problems that I use with my students so that they can be building these basics and getting the practice that they need. Anyway, product of powers law goes like this. If I have x to the 3 multiplied by x to the 4, that's the same thing as saying, this one here is like saying, please take 3 copies of x and multiply them. Okay, so there's x to the 3, or x cubed, and then multiply that by x to the 4. Well, please multiply by 4 more copies of x. That's x to the 4. And this is called expanded form, where I simply write the powers, x to the 3 and x to the 4, as a series of multiplications. I can look at that and see, wow, I've got 1, 2, 3, 4, 5, 6, 7 x's multiplying. So this is going to give me x to the 7 as my final answer there. Now, it would be cumbersome to have to do this every time. We want to memorize a law that we can use in this situation. And in these cases, we just add the exponents together. This is x to the 3 plus 4. Okay, so why do we add the exponents? Well, you can see it here. And so, again, we don't want to memorize the law without understanding why. In fact, forgetting the law and reteaching ourselves by going through the basics is a step in durable learning, learning that's going to be available to you when you see a challenging question like this on the SAT. So now let's take a look at a more challenging example that would be a quotient of powers law, where I am dividing things that have the same base. So here, I am going to first expand this. Now, I wouldn't recommend doing that except to show you how this law works. So I have 8 divided by 8. That's clearly 1. That's like 8 cookies and 8 people. Everyone gets 1 cookie. And then x to the 8 is going to be x times x times x times x. Okay, I'm a little bored. I don't want to write out any more x's times x to the 4, if you don't mind. That's 8 x's multiplying. There's 4 of them, and here's another 4. Okay, divided by x to the 4. So I'm going to write that one out for you. X times x times x times x. And then we're still going to be multiplying by y to the 3. That's y times y times y divided by y to the 7. Well, that's y times y times y times, I'm a little bored of writing all these y's. I still have 4 more to write, so I'm just going to write them as an exponent. Okay. Now I get to go out and get my cancel pen. This is my favorite pen to use. It's very handy. 8 divided by 8 cancels away to 1, so that goes away. X divided by x, it doesn't matter what x is. X is some number. Well, some number divided by itself is always 1. So that's going to cancel away and give us a 1. Same with this x divided by that x divided by that x divided by that x. And it leaves us just x to the 4 living upstairs. This y cancels that y, and so on, leaving us a y to the 4 living downstairs. So our final answer here, and we're all finished with this question, 8 divided by 8 was just 1. We don't tend to write that. We're left with x to the 4 on top and y to the 4 on the bottom. But we would like to have a rule to understand how to do this. And so here's the rule. Notice that for every x that was on the bottom, it took away one of the x's on the top. So that gives us our rule. I'm going to take these two, x to the 8 and x to the 4, and just write that as x to the 8 minus 4. When dividing exponents, we subtract the exponents. When dividing powers of the same base, we subtract the exponents. So that will give us x to the 4, but it's going to be divided by, well, we have y to the 3 multiplied by y to the 7. So if I do that over here, y to the 3 minus 7, I'll find that that gives me y to the negative 4. Oh, that's weird. What am I supposed to do with that negative exponent? This gives us the clue. Okay, tells us that when we have a negative exponent, it's the same thing as a positive exponent on the bottom. That would be the same thing as saying 1 over y to the 4. So I want my students to see this negative exponent and just say, okay, I just want to move you to the bottom of the fraction. If I find that something has a negative exponent and it ends up on the bottom of the fraction, it just moves to the upstairs. We're not going to need that for this particular problem, so I'll move past that. But just know that this is a confusing piece of information for many students, the negative exponent, and that's something that they're going to want to practice because it can be worth 10 or 20 points on the SAT. The next law that we're going to look at is the power of a power law. If I have r to the 6 squared, I can actually expand this exponent and do it this way. This would be r to the 6 multiplied by itself twice. So it would be r to the 6 multiplied by r to the 6. And then I could use my product of powers law, which would be r to the 6 plus 6. Two 6's adding together. That's r to the 12. Now what would happen if I had, say, let's go with a new color, x to the 3 to the 4. Well, in this case, what I'm going to do is, I can write it out again and expand it all, but I really just want to know the rule here. Here I'm noticing that I have 1, 2 6's, 2 of them, and I have that many 6's. So in this case, I can actually write that as r to the 2 multiplied by 6. When you're raising a power to a power, you multiply the exponents together. So actually here, x to the 3 to the 4, I'll have x to the 3 times 4, and that will give me x to the 12. Okay. So last thing that we need to look at, and this can be pretty tricky. We also need, in this question, to be so fluent with our exponent laws that we understand how to change the base of an exponent to solve an equation. Here, I have my unknown, and it's in the exponent. I want to find x. That's what this question is asking us for in this delta math problem here. And yeah, so, but my problem here is that the bases are not the same. I've got 36 over there and 216 over there. But because my math skills are good, I can recognize that 36 is equal to 6 squared, and 216 is equal to 6 to the 3. This is just something I know, and that my students are going to learn by working on a lot of problems like these. You'll just naturally build a memory for your squares and cubes, and they come up on the SAT, so you want this skill. And so now I can rewrite this equation like this. So 36, I'm going to write as 6 squared. I'll put that in brackets because then I want to raise that to the negative 3 because I had negative 3 there. And then 216, I'll write that as 6 cubed. But I put that in brackets because I have this power here. So that's to the 2x plus 2. All right. Now I am going to use the power of a power law to simplify the exponent on both sides. So here I have 6 to the 2 to the minus 3, so I multiply those. So 2 multiplied by minus 3 is going to give me negative 6. So that's my final power of 6 on that side. So this is 6 to the negative 6. Over here, I want to multiply these powers. This one against that one. And when I do that multiplication, let's expand that over here. That's 3 multiplied by 2x plus 2. This connects to the distributive property where that 3 multiplies that and that. So I have 3 times the entire bracket, so I will have 6x plus 6 on that side. So my final power of 6 over there is 6 to the 6x plus 6. Now, if 6 to the this is equal to 6 to the this, then these two things must be equal to one another. So let's equate those exponents. We have minus 6 is equal to 6x plus 6. So now we go ahead and solve that. Let's bring that equation up here. Negative 6 equals 6x plus 6. We can divide both sides of the equation by 6 to get minus 1 equals x plus 1. And then subtracting 1 from both sides gives us negative 2 is equal to x. Fantastic. So that's how you would solve that type of problem. And these types of things will show up on the test, so you want to have this skill. Now we've reviewed all of the basics that we need to reapproach this more challenging problem above. So let's dive in. Okay. So my first step is I'm going to start working from this side and see if I can simplify that. 8 to the x divided by 2 to the y. So let's rewrite that down here. 8 to the x divided by 2 to the y. Right now the bases are different, so I'm not able to apply any of my power laws. But I can recognize that 8 is equal to 2 to the power 3. That will get us a common base. So now I can say that this is equal to 2 to the 3 raised to the power x. Divide that by 2 to the y. And now let's resolve that exponent over there. Here we're going to apply our power of a power law. So we multiply the powers. So I'm going to multiply 3 by x. So that's going to be equal to 2 to the 3x, because that's 3 multiplied by x, divide by 2 to the y. Now I apply my quotient of powers law. I am dividing two powers that happen to have the same base, so I subtract the exponents. This will be equal to 2 to the 3x minus y is my exponent. All right. And now that's as simplified as I can get this expression for the moment. They gave us another clue up here. 3x minus y equals 12. So at this point, since 3x minus y equals 12, and that was given, since this was given, we can substitute that into the equation. This is just equal to 2 to the 12. There we go. Let's look for it in the answers. Dun, 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 there it is. Cool. So that's the easiest way through this problem, is to have all of those basics so primed and so ready that you can just fly through with the most straightforward solution possible. Another way to do this would be to say, I forget all of these things. I didn't remember them, but I'm at the test and I'm going to make the most of this. So I'm going to just try some value of x and y that would satisfy this equation and then go for it. So let's say that, let's say y is, what can we use here? 3 times x minus y equals 12. So I'm going to say, well, if x were 5, then y would be 3. And that's just one solution of this. 3 times 5 minus 3 does indeed equal 12, because 3 times 5 is 15, minus 3 equals 12. So let's let x equal 5 and y equal 3. Note y is positive 3 because the minus was already there in the equation. So then we can just go ahead and evaluate 8 to the 5 divided by 2 to the 3. And you could crunch this on a calculator. Let's try it and see what we get. It's going to be a big number, and you don't really want to do it. If this was not the calculator section, you wouldn't be too happy at this point, and you would want to be able to do it algebraically. But if I'm really lost, I could go 8 to the power 5 equals that big number, divided by 2 to the power 3 equals 4,096. And then I can go through and test these and see if any of those are equal to 4,096. And luckily enough, 2 raised to the power 12 gives me 4,096. So this is the answer anyway. Because this is true for all x and y, any one x and y can work. And that's a way to get variables out of the question so that you can simplify things a little bit and avoid doing algebra. And that's good to be inventive, but you want to ground your SAT practice in solid basics. So I would say approaching the problem in the way that it was intended in order to test your exponent laws is the best way to practice. However, don't let that get in the way of finding inventive solutions to different problems when you find yourself stuck on the test. And that's a great skill as well that can add 20 or 30 points to every SAT test you ever take. More than that, actually, I would say maybe you could add 50 points just by having that. I'm going to get in there and muck around with this question and try and drive it towards an answer, at least eliminate some answers. So I hope that helps you out for your next SAT. And I salute you for showing up for your learning. And I wish you all the best for your SAT success. Bye for now, everyone.